Hi, I'm Phil from Right Maths, and today I want to talk to you about circle theorems. There are 8 circle theorems in total, but today I only want to talk about 4 of them. And the first one I want to talk about is in the top right hand corner of my diagram, and it says that the angle at the centre is twice the angle at the circumference. So what does that mean? Well, here's the angle at the circumference, and twice that angle is 130 degrees. Well, you might say there are 2 angles at the centre, and there are indeed. One is a reflex angle, 230, and one is an obtuse angle. We have to be very careful which angle we're talking about. At the moment, the one that's furthest away from the angle at the circumference is the 130 degrees. So the 130 is twice the 65 degrees. If I move into the other segments, okay, so I moved to the bottom half of the circle, then the angle is 115. It's now half of the reflex angle, so half of 230 is 115, and so the angle at the centre is twice the angle at the circumference. The angles are as far away as possible. So the 115 doesn't go with the 130, it goes with the 230. Okay, so there are various depictions of the diagram, and I want to get you just familiar with all of them. The first looks a bit like an arrowhead, where the top angle is above the bottom angle, and it's largely symmetrical. But as I move further away, it becomes less and less symmetrical until the radius is directly underneath the diameter. So this radius is directly underneath the diameter. It looks a bit like a diameter with a triangle coming off it. So it looks slightly different, but the angle at the circumference is still half the angle at the centre, or the other way around. It's still true if we look below that radius, but you'll see the diagram looks slightly different. It doesn't look like an arrowhead at all. And if I move even further on, then the angle is no longer half of that 130. It's half of the 230, as we said earlier. So there are 3 or 4 showings of this diagram. First is an arrowhead. Second is a triangle and a diameter. The third looks slightly different, hard to describe. And the fourth is the smaller diagram when I go into the minor segment. Okay, I'll pop that back and we'll move on to the second diagram. Well, the second diagram is easily understood if we draw in 2 more lines on the first diagram. So I'm going to stop the video and do that for you. Okay, so there we go. I've modified the first diagram. It might not look different, but if I pull this new point K away, you can see that I've got now 2 angles at the top. They're both the same because they're both half of the 130 degrees. So they're both the same. I've pulled the 65 away from the other 65, and I've got this butterfly shape. I've got 2 radii on as well, the angles at the centre, but if I ignore those, then you can see that it looks very similar to the second diagram. And we say that the angles in the same segment are equal. What does a segment mean again? The segment is defined by a chord. So a chord runs part way across a circle. Well, it goes all the way across the circle, but it's not through the diameter. It's not a diameter. It gives a minor segment down here. It's called a segment because it looks rather like an orange piece. And of course, we've got the major segment at the top. So a minor segment and a major segment. If the angles are in the same segment, then they're equal. Okay, so wherever I move this point, it stays at 64, and this one stays at 64. But if I move the chord and change the size of the segment, then these 2 angles change, although they are both the same as each other. And it doesn't matter whether I'm in the major segment or the minor segment. I'm in the major segment at the moment, but if I pop down into the minor segment, then the two angles are still equal. So angles in the same segment are equal. The third one comes from this diagram as well, and I'm just going to move one of the points up into the major segment, and you'll notice that the two opposite angles here add up to 180. Well, that's because they're half of the angles at the centre, and the angles at the centre add up to 360, so these must add up to 180. So here's illustrated in the bottom corner. The opposite angles in a cyclic quadrilateral sum up to 180 degrees. So 95 and 85 makes 180 degrees, 80 degrees, and 90 and 90 also makes 180 degrees. Okay, if I move one of the points, these two opposite angles change, and if I move this point, then these two angles change, but they still add up to 180. So opposite angles in a cyclic quadrilateral add up to, or sum to, 180 degrees. The very last one that I want to look at is this one that says that angles from a diameter are right angles. I'll just get rid of that extra point that I had before, and then I'm going to look at this first diagram which says the angle at the centre is twice the angle at the circumference. Well, I'm going to make the angle at the centre equal to 180 degrees. There we are, a little bit tricky just to get it exact. There we go. So I've now got 180 degrees at the centre, and the angle at circumference is 90 degrees. Doesn't matter where I go. Even if I go into the other segment, it's still 90 degrees. So here we are. Angles from a diameter, there's a diameter, are always a right angle. Okay, and this of course is a diameter if I've got 180 degrees and it goes through the centre. So all angles from a diameter are right angles. Well, it doesn't matter which segment you're in. Okay, I'm going to stop the video now, and then I'm going to look at some practice questions, and you can do those. Okay, so here's the practice questions for you. Stop the video between the question and the answer. Okay, have fun. Okay, the angle at C is 64 degrees. That's because the angle at B must be 90 degrees because it's from a diameter, and then the angles in a triangle have to add up to 180 degrees. Well, the angle at C is 63 degrees because angles in the same segment are equal. Well, the angle at P is 104 degrees because opposite angles in a cyclic quadrilateral add up to 180 degrees. The angle at C is 44 degrees because angles in the same segment are equal. Okay, the angle at the centre here is 228. That's the reflex angle, but we were actually asked for the obtuse angle, and the obtuse angle is 132 because the angles around a point make 360 degrees. Okay, so the angle at A is 42 degrees. The angles in the triangle have to add up to 180, so 65, 73 and 42 make 180. The angle B is the same as angle A because angles in the same segment are equal, so B is also 42. Okay, so F is a right angle. It's coming from a diameter. So we've got F is a right angle. So the angle at E must be 57 degrees. That's because the 37, the 57 and the 90 have to add up to 180 degrees. The angle EFG is 68 because the three angles in this triangle EFG must add up to 180 degrees. And the angle GFD is 22 here because the 22 and the 68 have to add up to 90 degrees, and because F is a right angle. Okay, thanks for listening. Bye bye.